Okay, now if you see on the board, 4 more examples here, seeing that one. Y is equal to 1 plus d by dx plus 1 by 2 factorial d by dx whole square plus 1 by 3 factorial d by dx whole cube and so on. Right, fine. See, here order can be defined d by dx because everywhere if you see d by dx power only is going to be changes, but d by dx is common. So order is okay. Then what about degree? Right? So immediately children what they will say, sir, degree is not defined, sir. Degree is here now nowhere we cannot write it. So degree is not defined, sir. See, actually, if you look clearly, degree is defined. Okay, let me explain that one. If you see here, y is equal to, it is looking like 1 plus x plus 1 by 2 factorial into x square, 1 by 3 factorial into x cube. It is going on. So, what I can write it, this is nothing but expansion of e power x. So, what is x stands for? dy by dx. So, I can write it as x instead of x. I am going to write it as dy by dx. It means I am writing as y is equal to e power dy by dx. Am I right? Y is equal to e power dy by dx. Now, e if you send here, what it become? Log y base e is equal to dy by dx. Log y base e is equal to dy by dx. Now, if you see clearly, what is that? Order. Order is already we discussed. Order is 1. What about the degree? Degree also 1. Sir, you may have doubt. Sir, it is expressed log y. No, sir. How it will be degree is different, sir. Remember, I said logarithm or trigonometric functions. If you take it, differentiate trigonometric tan of dy by dx, sine of d square by dx square, log of d cube by dx cube. So the differential operator should not be expressed in terms of sine, cos, log. Even if it is expressed also, we are able to, if you are able to write it, say I think some next question I am going to explain you. If you are able to express that one, then it's fine. Already I explained the old question. Okay. Now coming to this one, what you can say? The order is 1, degree is 1. Now coming to this one, can you define what is the order and what is the degree here? See, the order is 3. It is clear because the highest power is 3. And degree, say I said you, condition number 1, it should not have the fraction. So now, but here 2 by 3. So then cubing on both sides. When you are making cubing on both sides, then into 3 and whole power 3. Then 3 cancel, right? Now 2 only left. So degree is 2. Degree is 2. Next one. Here order is 2. Then degree. Degree is not defined. Not defined. Because it is in terms of log. Right. Next one. Here, if order and degree existed, and if you think they are m and n, what is the value of m plus n? Fine. Now it is a fractions, like we have to take the LCM. Okay, let me multiply and do that one. It becomes d square y by dx square whole power 5 into dq y by dx cube, because that is the LCM, plus 4 into d square y by dx square whole cube plus this dq y by dx cube whole square is equal to d cube y by dx cube. After LCM I am sending this value to that side, x power 4 minus 1. Now if you talk what is the order and what is the degree. Okay, order, the highest order, whatever you are saying. See, highest order 3, I am saying here 2, here 2, here 3. So order is 3. No doubt it is easy to find out. Now matter is degree. Now degree, if you see this highest order power is 1 and here is 2, here also 1. So among this one, what is the highest order? 3. That among that one, highest degree will be 2. So the degree of this differential equation is 2 and the order is 3. Okay, fine. Okay, now the next topic is general and particular solutions of a differential equation. Okay, before going to the topic, see, in earlier sections we have learned, suppose x square plus 1 is equal to 0, or x square minus 1 is equal to 0, x square minus 1 is equal to 0, or x square plus 1 is equal to 0. Okay, next, sin square x minus cos x equal to 0. See, this is an algebraic equation, this is also algebraic equation, this is also trigonometric equation, algebraic and trigonometric equations now. Okay, these equations, if you solve it, you will get some solutions, whether they are all real numbers or complex numbers, right? So when you substitute back these real values or complex numbers, if it satisfies the given equation, then we can say they're all solutions, right? Fine. Now suppose if you have a differential equation d square y by dx square plus y is equal to 0. Okay. Now this is also equation, right? This is a differential equation. Now if you write something else in the place of y, for example y is equal to a into sine of b plus x, let us assume that it is a solution, right? Okay. Now y is equal to a sine of b plus x, if you write in this, if LHS equal to RHS, it happens. If it happens, then what you could say? It is the solution of the differential equation. If not satisfied, then it is not a differential equation. Then, okay, now our topic is what is general and the particular solutions. Now we got what is the meaning of the solutions, right? From here, we will go for general and we'll go for particular, right? Now, here A and B are called as arbitrary constants. Okay, constants, actually those values are fixed, but arbitrary constants are going to be changed, the values depend upon that. Okay, arbitrary constant. Then A of sine B plus x, right? We don't know the values of A and B. So those, and we said y is equal to A sine B plus x is the solution of that one. So if it is a solution and it contains the arbitrary constant, then it is called as the general solution. General solution. Okay, first when you are getting the equation and when you are getting the solution, that definitely it will be the general solution, right? Because A and B values you can write anything. Suppose you know the value of A 2 and B value, suppose some angle pi by 4, some angle, it means no arbitrary constant. So that what happens, y is equal to, it is 2 into sine of pi by 4 plus x. So no arbitrary constants are present. So in this meaning, what I can say, if a general solution does not have any arbitrary constant, then the solution is called as particular solution, right? Okay, now what we landed, general solution and particular solution. Let us solve some examples, then we can understand elaborately, right? Now we are in the exercise 2 from the NCERT. Okay, in the NCERT it is given clearly. Exercise 1, it is order and degree of the differential equation. Exercise 2, check whether the given function is the solution of the given differential equation or not. 2, that is exercise 2. Exercise 3, how to frame the differential equations. Exercise 4, exercise 4 onwards, how to solve the different types of differential equations, because we are going to get the functions, right? Okay, now exercise 2, what it says that verify that the given function y is equal to e power minus 3x is the differential equation, is the solution of the given differential equation or not. Okay, now take solution. Given that y is equal to e power minus 3x. Now differentiating on both sides. Differentiating on both sides, what we get? Differentiating on both sides, we get, see, dy by dx is equal to, differentiated, what do you get? Minus 3 into e power minus 3x. Because the e power x differentiation is e power x. E power x differentiation is e power x only. But whenever the coefficient, if it is present, e power ax, then you have to take it, then it become a e power x, a e power ax. Now minus 3 e power minus x. Again differentiating on both sides with respect to x, we will get it d square by dx square, which will become minus 3 into, again minus 3 into e power minus 3x. Then what you get, d square by dx square will be 9 into e power minus 3x. Now what is our duty? Check whether the given function is the solution of the differential equation or not, right? Okay, how do you check it? That e power minus 3x, we have to substitute in this as y, and dy by dx value we got it, substitute, and d square y by dx square value we got it, substitute everything. So now the function it is d square y by dx square plus dy by dx minus 6y. This is LHS. Now d square by dx square, what I got it, 9 e power minus 3x plus dy by dx, I got it as minus 3 e power minus 3x minus 6 into e power minus 3x. See, on whole if you see, plus 9 minus 9, it is 0, which is nothing but RHS. See, what we got it, from LHS to RHS, we got it like actually it is 0. LHS equal to RHS, we got it now. So then what we can conclude that the given function y is equal to e power minus 3x is the solution of the given differential equation. Okay, let us see one more problem. Right, one more question on the board. If you see, verify that y is equal to a cos x plus b sin x, where a comma b belongs to R, is the solution of the differential equation or not. As usual, what we did the word sum, take y is equal to a cos x plus b sin x. Right, differentiate first one time. dy by dx is equal to, for a cos x, it is minus a sin x plus b cos x. And here d square by dx square, again do differentiate it. D square by dx square, then minus a sin x, it will become cos x. For b cos x, it will become minus b sin x. Right? Okay. Now this I am taking number 1. Now d square by dx square, see, I can take minus common out. So a cos x plus b sin x. Now see, number 1, if you apply here, what it become? D square y by dx square is equal to minus y. Now d square y by dx square plus y is equal to 0, we got it. See, one thing, d square by dx square, you can substitute in the given differential equation, and y also substitute. If you get 0, one way. Or from this process, if you get the differential equation also, it is enough. So now I prove that one, the given differential equation. So what I can say, the given function y is equal to a cos x plus b sin x is the solution of the given differential equation. This completes the solution. Now one more question on the board. If you see, what is trying to say, if xy is equal to log y plus c, and we have to prove that y dash equal to y square by 1 minus xy, or we have to show that this is the solution of that one. So whatever the way, if you think, no issue. Now according to the question I am taking, this is the solution of that one. So now solution, given that xy is equal to log y plus constant. Now differentiating on both sides with respect to x, we get. With respect to x, we get. So what we get? Let us see now. Now here xy. So now xy, how it is then? It is in the form of ub. So ub formula we know. Differentiation of ub will be u v dash plus v u dash. We know that. So then if you apply x y dash plus y x dash, right? And log y, if you do 1 by y, and y function if you do y dash plus for constant it is 0. Clear? Now I want y dash as a subject. Okay, let me write first xy dash. It is y into x dash. X dash means differentiation of x dash is 1 plus, is equal to y dash by y. Now do cross multiplication. You can get the answer xy y dash plus y square is equal to y dash. Now I want y dash as a subject. Then y dash or this term totally carry. So y square is equal to y dash minus xy y dash. Right? Now from here what I will get it, y square is equal to y dash, if you take out common, 1 minus xy. Then 1 minus xy you carry here. So y square by 1 minus xy is equal to y dash. Now what we got the y dash if you substitute in this, both LHS equal to RHS. Or if you say that, sir, I proved it this one here. Okay. So either if you substitute in that LHS equal to RHS, or whatever the differential equation he asked, if you bring it, both says same. Now what I can conclude from this one, xy is equal to log y plus c will be the solution of the given differential equation. Right. This completes the solution. Now, children, along with this one, homework will be shared to you. That homework as early as possible you try to complete, and please share your answers to my to the respective groups. Then I can correct and get back to you without fail. Children, with this content, I am going to wind up today's section. In the upcoming section, we are going to learn few more examples of this one, and we are going to learn few more types of models based on that, finding the general solutions also. Okay. So thank you. Bye bye.